here we go. We have a question LCA in a BST. So before jumping into the problem, I want to show you something. So this is the 300 video on our channel, and this is the last video on the Geeks for Geeks. From tomorrow onwards, I will be starting lead code videos, and this is my profile. I have currently 176 days active. So this is my streak, and I will no longer be active on Geeks for Geeks. So from tomorrow, my streak will be broken, and this is the total number of problems I have solved. And as you can see, this is my current graph, and if I show you 2024 graph, so I don't know why the heat map is not given. Let's reload it. Still not given. Yeah, so this is my 2024 graph. I have more than 176 streak because on this day my streak was previously broken, I think more than 2 times. Yeah, so and this is my 2023 graph. 2023, yes, so this is 2023 graph. And if I show 2022, I was very active for consecutively 3 years on this platform. Still, I think there's a issue on the backend. Yeah, so this is 2022. On July, my my end sem was happening. That's it. That's all about it. And I will no longer be posting videos on Geeks for Geeks. I will be posting lead code videos. Now let's start the question. So we have a question given a BST and 2 nodes N1 and N2. 1 second. Yeah, so we have given a tree and 2 nodes. You may assume both the nodes exist in the tree. We need to find the LCA of the given 2 nodes. LCA means lowest node that has both N1 and N2 as descendants. So in this we have 7 and 8. So 7 and 8, descendant is 7. So if I have 3 and 7, its descendant is 5. If I have 4 and 8, its descendant is 5. And if I have 6 and 8, its descendant is 6. For this tree, we have 8 and 14. 8 and 14, its descendant is 8. If I have 8 and 14, its descendant is still 8. Yeah, if I have 8 and 4, descendant is still 8. For 10 and 14, the descendant is 12. For 10 and 22, the descendant is 20. For this, we need to find for 1 and 3, the answer is 2. That's about the problem description. I hope you got to know what LCA is. Now let's build the approach. So I have given this graph and these nodes. First of all, the main thing, if your N1 is greater, just swap N1 and N2. Actually, N1 and N2 is not values, it's nodes. So the first thing that we need to take care is if N1 data, it's N1 data is greater than N2 data, so just swap N1 and N2. In this case, our N1 is much smaller. Okay, that's fine. So we have given these nodes. This is BST, we know. So first of all, the first condition is both the nodes on the left side. Yes, both the nodes on the left side. So just return the node that will be passed from the left side. So we have given this node and we are on to this. Is it equal to N1? Yes, so this is our answer. That's as simple as that. For the second tree, where is the second tree? Yeah, here. So N1 is smaller. Okay, is for the root node is N1 and N2, means both the nodes present on the left side, means n1 is smaller than this, and n2 is also means 7 is smaller than 5, and 8 is also smaller than 5, which is not true. And we know both the nodes is greater than 5, so we will return the value from here. Is it equal to, and is n1 equal to 6? No. Is n2 is equal to 6? No. So just return the data from the right side, because we know n1 and n2 both the nodes is greater than the current node, so we return data from this side. Is it equal to n1? Yes. So we are returning this node. So from at on this stage 7 will be returned, on this stage 7 will be returned. So this question is very simple. Now let's code this. First thing is to check, is our root null? If this is null, it means just return root, or root data is equal to n1 data, then root is your answer. If root data is equal to n2 data, so just root, return the root. Then is n1 data greater, or n2 data is smaller? If your n2 data is smaller, so just swap the nodes n2 and n1. Now this is the main thing. n1, we know n1 is smaller than n2. So if n1 is on the left side and n2 is on the right side, this is not root, this is root data. So root data, and n2 is greater. So it means n1 is on the left side and n2 is on the right side. n1 is smaller, so it is present on the left side, and n2 is greater, so it present on the right side. Let's suppose for this example we have given 3 and 7. So we have given the current node as 5. Is 3 on the left side? Yes. Is 7 on the right side? Yes. So your answer is 5. So just return your root. Root is your answer. Else if n1 is smaller than root and n2 is also smaller than root. For example, we have given this, and for this tree we have given 4 and 3. So for the fifth node, n1 which means 3 and n2 which means 4, both the nodes present on the left side. So whatever node that we are getting from the left side will be our answer. So root left n1 and n2. Then else condition, both the nodes on the right side, so just return the node present on the right side, n1 and n2. That's it, and I hope it will work. Yes, let's submit this, and let's talk about time and space complexity. For this function, the time complexity is order of n, because we are visiting a node only once, and time complexity is order of n, and space complexity is order of height, because the recursive stack will store order of h items, and time complexity is order of h, and space complexity is order of n. Yes, right. I was wrong about the time and space complexity, but space complexity is order of n, not order of 1. Space is order of h only, because we are traversing and recursive stack will store the items, and time is order of h, because we are going only one side, not all the sides, not visiting each and every node. We are visiting one side, one path only. So that's why the time complexity is order of h, and space complexity is order of h, and space is incorrect here, or they are not including recursive stack. That's it. We have solved this question. Code is given in the description box, and share your thoughts. What are your views on this POTD streak? And my streak will be broken, and I will be starting lead code videos. That's it, and thank you all for watching this video.